Observatory. Here is a really nice picture that shows kind of an overview of the observatory. Isn't that beautiful? I look at this and sometimes I think this is the visitor center. It is not. This picture was taken from a ranch to our northwest. I don't know. This is the ranch, not the visitor center. The visitor center's there. Let's just zoom in a little bit. And what you can see is that there are two mountains. The one on the right is called Mount Locke, and the one on the left is called Mount Fulks. Mount Locke has two big white domes on it. Mount Fulks has the one silver dome, plus some smaller white domes on it. And we are going to visit both mountains today. Yay. But let's talk about a little bit of history. We are here at McDonald Observatory because this guy, William J. McDonald, he had nothing to do with the hamburger franchise. So do not expect hamburgers or fries today. But he was a banker and trained as a lawyer, and he lived and worked most of his life in Paris, Texas. And he was kind of a weird guy. He was, what was weird about him? He was a lifelong bachelor. He didn't have any kids of his own. He liked science. He was frugal. He, for example, I've heard that he shoed his horses himself. And that he owned one of the very first automobiles in Paris, Texas, and he hardly ever drove it. But he did like science, and when he died, he left the bulk of his estate to the University of Texas, and these words were in his will. He wanted the money to be used to build and equip an astronomical observatory, both for research into astronomy and for the promotion of the astronomical science. I get to do the promotion part. And so that was pretty cool, wasn't it? It was a big surprise to several different entities. It was a big surprise to his family. Although he was a lifelong bachelor and didn't have kids of his own, he did have nephews and nieces who had expected to inherit his estate, which was a little over $1 million. Wouldn't you have wanted that in 1926? Yes, you would have. So there was kind of an inevitable court battle over the will. The family argued that he was not of sound mind and did not understand the meaning of money. Okay, think about this. He's a banker. His estate comes to a little over $1 million. Do you think he understands the meaning of money? Yeah, probably. Anyway, so the family they settled out of court. The family members each got a little more money than they had expected, and the University of Texas got the rest. It was a surprise to the University of Texas that he left them his money. Here's a picture of the University of Texas from around that same time. You can see that, are any of you from Austin, or have you been to Austin, some of you? Yeah, okay. So this is the iconic tower. You can see it's under construction here. There's a big construction crane and the walls are open, etc. That was happening all back around that time. University of Texas was surprised to get Mr. McDonald's money for two reasons. One, he had not attended UT. So it wasn't the Alumni Association after him, like they are after me because I'm so rich. No, they're not. Anyway, but the other reason was they did not have an astronomy department. So, put yourself in their shoes. You're a university, you're growing. Somebody wants to give you $1 million to build an observatory, but you don't have any astronomers. What are you going to do? Find one. Well, yeah, that's not what the money was for. So here's what they did. They sent a bunch of letters, and they sent them to universities that they knew had astronomy departments, and they said, this is our situation, what is your advice? And the answer they got from the University of Chicago was the answer they went with, and that answer was, you would team up with us. Here's what the University of Chicago's observatory looked like at about that same time. University of Chicago's observatory is the Yerkes Observatory. This is in Williams Bay, Wisconsin. That's about 100 miles north of Chicago. It's on the shores of Lake Geneva. Would any of you like to be there right now? No, because it's cold and wintry there. Yeah. Do you think you'd like to be there in the summer instead? It's probably pretty nice. I think they have mosquitoes. There are more trees there. But I want to point out a thing or two about this observatory. The Yerkes Observatory is built on the old style, where everything is in one building. You can see there's 3 domes that you can see, and they're all part of one building. got domes on separate mountains, and there's separate buildings, and that's the more modern style of observatory. This is the more old style. Okay, so what the University of Chicago said was, you would team up with us, and so we did. Here's the University of Chicago's, the big dome houses the largest refractor telescope in the world. Here's a picture of it. It was the largest refractor telescope in the world in the 1920s when McDonald Observatory was established. It's got this is a telescope, and this is the style of telescope that maybe you're used to thinking of when you think about a telescope. It's got a lens at one end, place to look from the other end. Okay, lens is up here. You see the human in this picture? Yeah, this is a really big telescope. That's extra long. I always forget how long it is, but it's long. It's like 60 feet long, and 40 inches turns out is the biggest that you can make a lens for it to work. If you're supporting glass by its edges and it's thicker in the middle, that glass sags under its own weight. And so bigger than 40-inch lenses have never been successfully used in telescopes. So this is still the largest operational refractor telescope in the world. If you want to collect more light with a telescope, you don't do it with a telescope that uses a lens. Aha. So that's what Yerkes had. They were looking for a place. They had the astronomers. They didn't have the money. We had the money. We didn't have the astronomers. So we teamed up. And the deal with the University of Chicago was that the University of Texas would build McDonald Observatory, and the University of Chicago would operate it for 30 years. And during those 30 years, they would help the University of Texas build up an astronomy program, and they would operate the observatory. So here's the first director of McDonald Observatory. The man is named Otto Struve. He came from a very long line of astronomers. I think his grandfather was an astronomer, and his father, and some uncles, and whatever. And he was the director of the observatory. He was also the director of the Yerkes Observatory, so he had quite a commute, and you couldn't do that work by Zoom back then. So I don't know what all he did, but there he is. And our first telescope here at McDonald was named in his honor, and here's a picture of it. This is our 82-inch Otto Struve reflecting telescope. So instead of a 40-inch lens, we collected focused light with an 82-inch mirror. Which means you can collect a whole lot more light. Did any of you go on the 82-inch telescope tour today? Okay. We do it every once in a while, about once a month. We do a tour to this telescope. One of the reasons we don't go there more regularly is that the elevator's broken. So it's not really accessible to anybody who has any kind of physical difficulty, and there's not as much space at the dome floor. So this is more like a special history tour that we do now and then. So that's our 82-inch telescope. We love this telescope. I love how kind of steampunk it looks. But when it was finished in 1939, this telescope was the second largest telescope in the world. It's not anymore. It's not even the second largest telescope here at McDonald, but it still gets used on a regular basis for research. So that's our first telescope. After the University of Chicago operated McDonald Observatory for 30 years, then the University of Texas took over. By then, there was a tiny little astronomy department at the University of Texas, and the new chair of that department is this man, Harlan Smith. And he got here in 1963, and by then we had two telescopes. We had the 82-inch, which was large but kind of old, and we had a 36-inch telescope, which was newer but smaller. And what Dr. Smith wanted was a large modern telescope. Now, was anything happening in the 1960s that would make us want maybe to think more about space? The moon was happening. Yeah. And so Dr. Smith managed to find some funding with NASA. I'm going to just skip past this view. I don't know, my slides are out of order. This is a picture of Apollo 11 launching in 1969. Our telescope, our 107-inch telescope that we are going to visit, had been completed by 1969, and much of the funding was from NASA. And the reason we like to think about the Apollo missions and our telescope is that the Apollo 11 astronauts left this on the surface of the moon. And that thing holds some reflectors. And why do we care if there's reflectors on the moon? Because from our 107-inch telescope, we shot a laser at the moon. Aha! Here's a picture of the laser going to the moon. We shot a laser at the moon. Now, it took a little bit of hunting around to get the laser light to hit a reflector that's this big at a distance of 250,000 miles. But eventually they hit it, and then it had to be the right kind of reflector. If it was just a mirror, think about this. Laser light would have come in from Earth, hit that mirror at some angle, and reflected off into space, never to be seen again. That's not what our reflectors are. Instead, they are prisms that are called retroreflectors. And what that means is, this is my prism. I know, it looks like a gang sign, but it's a prism. Light comes in from any angle, it reflects internally, and it returns right back to its source. So, once we hit the reflectors on the moon, some of the light came back to our telescope. We could send a pulse of light to the moon and it would come back, and we could time that pulse and determine very accurately the distance from the Earth to the moon. So that process is called lunar laser ranging, and it was something we started right here with our 107-inch telescope. We continued doing laser ranging with this telescope for a number of years, and then eventually the laser was moved to our other mountain over to Mount Folks. And then several years ago, lightning struck the telescope, and the decision, and I think also funding ended, so those things happened at about the same time. The decision was made not to repair the telescope, but we are continuing, and we will be doing more laser ranging in the future, and I will get to the reason why in a little bit. I want to talk about the 107-inch telescope right now. When it was completed in 1969, it was the third largest telescope in the world. So we like being up there near the top. I don't think we've ever been number one, but whatever. Anyway, so this is kind of the view you're going to get. One of the things that, you know, we have these beautiful pictures of these telescopes where the dome's open, you can see the light coming in. We are not going to open the dome during the day. We have a pretty strong rule against doing that, but we do open the domes during the day if there's a fancy photographer coming to visit. So that's why the domes are open in some of these images. So anyway, there's our 107-inch telescope. We will go there, we'll talk about how it works and who gets to use it, and we'll probably be allowed to move it around, which is always really fun. So we will see that telescope, and then after a number of more years, we built and completed the Hobby-Eberly Telescope. Hobby-Eberly Telescope is on our other mountain, on Mount Folks. It's in this shiny silver dome, and the Hobby-Eberly Telescope is one of the largest telescopes in the world. Not the largest, of course. It's number 2. The Hobby-Eberly Telescope is 10 meters across and 11 meters high. And the largest telescope in the world is the Gran Telescopio Canarias in the Canary Islands. That is 10.4 meters across. So it beats us by this much.
It's until the one in Chile is going to be.
Until the one in Chile, yeah, and the other one, yeah. So it's always when our giant Magellan telescope gets completed, then maybe we'll be number 1 at least for a week. So the Hobby-Eberly Telescope collects and focuses 10 meters worth of light using an array of mirrors. Not just one giant mirror, but a whole bunch of small ones. So here, these hexagons that you see, these are the mirrors. This picture was taken from an angle that we will not get on the tour. We're going to be down below, looking up at the mirror, and we won't get this view, so I wanted to make sure you saw. Each of these hexagons is a mirror, okay? And each mirror is curved a little bit, and when we put it all together, we have a 10-meter wide curved array of mirrors. If we continued adding hexagons, we'd end up with a giant soccer ball, sort of. Okay, does that make sense? All right. So 91 hexagonal mirrors, and out in front of the visitor center, we have models of our 3 big telescopes. We have a big round circle of concrete that is the size of the 82-inch telescope. We have a slightly bigger round circle of concrete that's as big as a 107-inch. And then we have 91 hexagonal chunks of concrete that are the size of the Hobby-Eberly. And I would encourage you to to stop and take a look at that on your way out when we head out for the tour. Anyway, so that's our third telescope, and that is where our tour is going to start today. We're going to start at the Hobby-Eberly Telescope, and the reason for that is that it's winter time. You probably knew that. And in winter time, the sun sets early, and the team at the Hobby-Eberly Telescope gets the telescope ready for the nighttime operations early, especially on Saturdays. On Saturdays, somebody comes up at maybe 4 in the afternoon, turns off all the lights in the dome, and makes it so we can't see the telescope. So we like to get there earlier before all the lights get turned off. So we're going there first, and then we'll go over to the 107-inch and see that telescope and watch it move and stuff like that. So that's our Hobby-Eberly Telescope. There's one more telescope I'd like to talk about, and that is our giant radio telescope. This is our 12-meter geodetic observatory radio telescope, and it's just behind the visitor center. I hope you noticed it. Yeah, it's not a satellite dish. It is a telescope, and the McDonald Geodetic Observatory is a relatively new entity here at McDonald. It is it and other geodetic observatories have been placed all around the globe to do studies of the Earth. So we're using astronomy to learn about the Earth. And the radio telescope, what it does is when it's running, you'll see it move and it'll be pointing at things, and it moves pretty often and pretty fast. That's fun to watch.